Welcome back to the channel. Watch the video until the end. Leave a like and subscribe to the channel to support us. The enigmatic images from the Messenger probe have revealed a lot about Mercury, but it begs the question, can this planet really be so close to the Sun? It's incredible how exploring Mercury is considered a technical challenge due to its proximity to the Sun. Probes must withstand extreme conditions, but it's essential to learn more about this celestial body if we want to solve the mysteries of connections in our solar system. A question naturally arises. What new knowledge will the Bepi-Colombo mission, which is headed towards Mercury, bring? Mercury has long been considered a mystery of the solar system. Being a tiny dot that periodically passes in front of the Sun as seen from Earth, studying and observing Mercury is extremely difficult. To see it, one must look in the direction of the sunlight, making it hard to capture this small space object as a single entity. In the Middle Ages, Mercury created confusion, sometimes being mistaken for a double planet or another fictitious planet called Vulcan. Only in 1974 did the Mariner 10 mission take the first pictures, photographing 45% of Mercury's surface. Thanks to Mariner, we know more about the planet's temperatures and magnetic field. In 2004, the Messenger probe reached Mercury's orbit and remained there for over 10 years. By the end of the mission, in 2015, we had obtained hundreds of thousands of photos of this fascinating celestial body, allowing scientists to know almost the entire surface of Mercury. The discoveries were surprising. This small planet shows a surprisingly lively geological life. Researchers have gained a more precise understanding of Mercury's internal composition and its diverse geological structures. One of the hottest regions on Mercury is the Caloris Basin, with temperatures reaching 427 degrees C. This hotspot was probably created by a massive impact crater with a diameter of 1,550 km. The Pantheon Fossae is a unique structure of radial pits radiating from a central point, likely formed due to tectonic activity or planetary cooling mechanisms. Enterprise Rupes, the largest known scarp on Mercury, is a result of shrinkage caused by core cooling processes and extends for over 1,000 km across the planet's surface. The Rachmaninoff crater, rather small with a diameter of 290 km, is dominated by an annular chain of high peaks of likely volcanic origin. Another significant crater is the Rembrandt crater, with a diameter of 716 km, where researchers found numerous small geological formations and precious clues about Mercury's turbulent past. Surprisingly, in the coldest region around Mercury's North Pole, called Regio Borealis, scientists suspect the existence of water ice in deep craters that exhibit intense and permanent shadow conditions. Finding traces of ice so close to the Sun was considered a miracle of astronomy and planetary research. An interesting fact about Mercury is that the planet is smaller than the solar system's largest moons and slightly smaller than Pluto. With its dense, crater-filled surface, it is somewhat similar to our moon. Mercury has no natural satellites and possesses an extremely thin atmosphere, called an exosphere, which is unable to retain a stable atmosphere like Earth's. Even Mars, despite being a planet with very different characteristics, has a denser atmosphere than Mercury's. Mercury's orbit around the Sun is highly elliptical, ranging from about 46 million kilometers at perihelion, the closest point to the Sun, to about 70 million kilometers at aphelion, the farthest point. A year on Mercury, i.e., a complete orbit around the Sun, lasts only 88 Earth days. Interestingly, Mercury's rotation period and its orbit are tied by a 3-2 resonance phenomenon, meaning that for every 2 orbits around the Sun, Mercury rotates 3 times on its axis. As a result, a day on Mercury, from one sunrise to the next, is 176 Earth days long. Mercury's axis of rotation is almost perpendicular to its orbital plane, with an inclination of only 0.034 degrees, meaning there are no seasons with significant temperature differences on Mercury. Temperatures on Mercury are extremely variable. In the sun-exposed part, they can reach 427 degrees C, while in the night part, they can drop to 973 degrees C. These extreme temperature differences are due to the planet's thin atmosphere, which is unable to retain heat. Mercury's surface has been largely shaped by intense volcanic and tectonic activity. After about 3.8 billion years without major upheavals, most of the plate movements today are due to the contraction of the planet's core. Being on Mercury would be an extreme experience. During the day, the view would be hindered by a blinding sun, while the night would be incredibly cold and dark. The sun appears about 3 times larger in the sky of Mercury compared to Earth, and due to the planet's slow rotation, Mercury experiences long periods of day and night, with each day lasting about 176 Earth days. The air on Mercury is extremely rarefied due to its exosphere, composed mainly of hydrogen, helium, oxygen, sodium, calcium, and potassium. However, the proportions of these gases do not compare to a true atmosphere. The atmospheric pressure on Mercury is almost non-existent, comparable to the vacuum of space. These conditions mean that Mercury cannot support weather phenomena like wind, rain, or cloud formation. The Bepi-Colombo mission, jointly developed by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, was launched on October 20, 2018, with the aim of studying Mercury in more depth. It is expected to enter orbit around Mercury in December 2025. The mission's goals include answering questions about the formation of the solar system and the processes that led to the formation of the inner planets, as well as investigating whether Mercury formed in another part of the solar system and what fate awaits it. Mercury still hides many secrets that we await to unveil. Its exploration will help us better understand not only this small and mysterious planet, but also the complex processes that govern our solar system as a whole.